Alright, so welcome to another video. In this episode, we are going to look at how we can derive the quadratic formula. Alright, so now this is very powerful. This quadratic formula is very powerful and is very versatile and essential to in mathematics, as that ensures us, right, to always make sure we have a right solution, or find the root of a quadratic equation with efficiency, right? So this is very important because it provides a universal, reliable, and systematic way to solve any quadratic equation of this form: a squared as squared plus bx plus c equals 0. So always the quadratic formula helps us to solve any equation of this form, no matter the kind of equation. So far as the word quadratic is concerned, the quadratic formula will handle it perfectly without any problem, right? So here, this is how we talk about it. The quadratic formula or the quadratic function is governed by this rule. Is governed by this rule. Right? Is governed by this rule. F is to x mapping onto as squared plus bs plus c. Right here, we can change the is to, right, the mapping rule to an equal to sign. So we can say that f of x is equal to as squared plus bs plus c, right? So here, if we are able to do this, then we can say that our f of x is equal to y. That is the process we can use to derive the formula for the quadratic formula. So here, if f of x is equal to y, then we can say that y should be equal to as squared plus bs plus c, right? This will only be a quadratic formula or a quadratic function if and only if a is not equal to 0. If and only if a is not equal to 0. Why do I say that? If a is equal to 0 in this, then you are no more having a quadratic function, or right? So here, a should never be equal to 0, right? So here, how do we go about it? First of all, make sure that you factor out the coefficient of s squared, because we are trying to apply or employ the idea of the completing of squares method, right? So if you want to employ that knowledge into this, then you have to make sure that the coefficient of s squared is unity, which is 1. So we divide the coefficient of s squared by a, and that we factor the a out, so we have s squared inside plus b over a x plus c over a, right? So once you have this, then you can look for the coefficient of x, right? So the coefficient of x over here is b on a, right? So the b on a, what you do is that you multiply the coefficient of x by half. So multiplying the coefficient of x by half we are going to have b over 2a, right? So this result you have right here, square it. So if you square this, then you add and subtract to this equation you are having right here. So we have y equals a into s squared plus b over ax plus b on 2a all squared, add, right? So we are going to subtract, so minus b over 2a all squared plus our c on a. Right, so once we have this, then we factorize these three terms into a perfect square, right? So 1, 2, 3 terms, we combine them to a perfect square. So we have y is equal to a into x plus b on 2a all squared, right? Minus b squared over 4a squared plus c on a, right? So once you have this, then you find the LCM for this. So when you find the LCM for that, you have y is equal to a into x plus b on 2a all squared minus, when you find the LCM for this, right, you have 4a squared. So this here we have minus b squared plus 4ac, right? So we can say that we have y equals a into x plus b on 2a all squared minus b squared plus 4ac over 4a squared. Right, so once we have this, then what do? We are interested in the points, right? So here we say that y is equal to, don't forget that we divided through by a. So once we are done with this, then we multiply through by the a. So we have a into x plus b on 2a all squared, right? Plus 4ac minus b squared all over 4a squared times a, right? So we have y is equal to a into x plus b on 2a all squared. This will take one of this, so we have plus 4ac minus b squared all over 4a, right? So this we have here can be written in this form, y equals x plus y equals x minus b, y equals x minus p all squared plus q. This we have here is written in this form, right? So this we have, we can say that we have our b on 2a equals minus b, right? Comparing this and this, right? So once we have that, then we can say that our p is equal to b on 2a, right? And this right here becomes our line of symmetry, our line of symmetry of a particular curve, right? And then comparing this to that, we say that our curve is equal to 4ac minus b squared over 4a, right? And this is also the value of Q, right? So when you combine this and this, then we have what we call the minimum or the maximum turning point, right? So here, the P and the Q is equal to minus B on 2A, comma, 4AC minus B squared over 4A right here. So this becomes your turning point. This is the turning point of a curve. So this is how we find the turning point of a particular curve, right? So here, if you are given a function, to find the turning point, right? For instance, you are given 2s squared plus 2x plus 2, and you have to find the turning point of this function. The turning point will tend to be minimum or maximum, provided the coefficient of s squared is positive, right? That is the coefficient of a, s squared, which is the a. If a is greater than 0, then we have a minimum turning point. And if a is less than 0, then we have a maximum turning point, right? So when you draw a graph and you have something like this or something like this, then this is your maximum and this is your minimum, right? And this section where your curves meet, this point, right, becomes your line of symmetry, right? This point becomes your line of symmetry where the line cuts the curve into two equal halves, becomes your line of symmetry, right? And that is the value of x, right? Or this. Good. Now let's go on and look at how we can find the zeros. The zeros will lead us to the quadratic formula. So now we had y equals a into x plus b on 2a all squared plus 4ac minus b squared over 4a, right? So once you have this and you want to find the zeros, right? What you do is that you set the equation to 0 and find the values of x, right? So when you set the equation to 0, then you find your value of x. So here, when you set this to 0, then you're going to have 0 equals a into x plus b onto a all squared plus 4ac minus b squared over 4a, right? So we want to find the values of x, right? So we have this comes here, right? Or we maintain this, then we bring this here. So we're going to have b squared minus 4ac over 4a is equal to x plus b over 2a all squared, right? So here we don't need this a here, so we divide by a, right? So we have our x plus b onto a all squared is equal to b squared minus 4ac over 4a squared, right? And here we need the value of x, or we need x, so we take square root on both sides, and that is going to be plus or minus. So this cancels this, right? So we have our x plus b onto a is equal to plus or minus square root of b squared minus 4ac over 4a squared, right? So here our x plus b onto a is equal to plus or minus, this can be expressed as b squared minus 4ac over square root of 4a squared, right? And this is s plus b onto a is equal to plus or minus square root of b squared minus 4ac over 2a, right here. You know, the square root of 4a squared is 2a, right? Now you are interested in x, so you move this to this side, right? So we have our x is equal to minus b over 2a plus or minus square root of b squared minus 4ac all over 2a, right? So this is the derived formula for the quadratic, or the quadratic formula. So this has become, or this will be the formula for the quadratic, or the quadratic formula. So we have this to be the formula derived for all quadratic functions. If you want to solve any quadratic function, you can use this. So hence, this is how we derive the quadratic formula. All right. So in finding the zeros, it just equates your previous step to 0, and then you find the values of x. All right. So here, that's it. Thank you very much for watching. I really appreciate your time. Don't forget to press on the notification bell, and I'll give you more content. Bye bye.